Hello friends and my dear students, I welcome you all to my channel. If you are new to this channel or not yet subscribed, I will highly request and suggest that you support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I have seen that most of those viewers who watch my videos are not yet subscribed. Like 90% or 98% of the viewers are not yet subscribed. If you are watching my videos on regular basis and if my videos are beneficial to you, then please support me by subscribing to my channel. That way it will help me grow my channel, and it will also motivate me to come up with this kind of videos on regular basis. Thank you. So this video is part of my playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. So this is part 2 on the topic Laws of Exponents from the chapter Exponents. This is class number 3. If you have not watched the previous two classes where I discussed about the introduction of exponents and division and multiplication of rational numbers in exponential form, if you have not watched those two videos, I highly suggest that you please watch those videos first and then you continue to watch this video. In this video, I will discuss about simplification of exponents. By exponents, I mean rational numbers in exponential form, and how to solve an unknown variable as a unknown variable in the power or exponent in a given equation involving exponents of rational numbers, and we'll solve few problems from the exercise 5a. So let's start. Okay, so as usual, I have my notes on the left hand side, and I will on the right hand side I will discuss and solve the problems. So the laws of exponents that I will discuss for today's video that will help simplification and solving are the laws 6, as you can see on the notes, the laws number 6, 7 and 8. Specifically these three laws will be used. So what are the let's understand these laws. So the sixth law says that if you have a product of two exponents, that is a to the power n. This is one exponent. I mean a is a number, non-zero number. It could be a integer or a rational number. A multiplied by b to the power n. So we see that it's a product of two exponents where the exponent is same, that is n. This can be written as, merged together, can be written as the product of a and b raised to the power n. Now this is both way. I mean if you have, this is both way, like 2 to the power 5 multiplied by, let's say, 5 to the power 5, you can write it as 2 into 5 to the power 5. This is nothing but 10 to the power 5. You can also do the reverse thing, like if you have, let's say, 6 to the power 4, you can write it as 6, you can write it as 2 multiplied by 3 raised to the power 4, and now you can separate out the factors in the product, so with the power, so this becomes 2 to the power 4 multiplied by 3 to the power 4. So this was the law number 6. The law 7 says that if you have this kind of equation where two exponents are being equated, the first being a rational number a by b raised to the power m equals to a rational number c, another rational number c by d raised to the power same power m. If the powers or the exponent in an equality is same, this will imply the base is same. Meaning, if you have two exponential form and they are equal, and if the exponent, that is the power or the exponent or the index, is same, then the base will also be same. This will imply a by b equals to c by d. Since the two exponents, that is a by b raised to the power m, is equal to c by d c by d raised to the power m and the exponent, the power m is same, so we can say that the base will be same. Reversely, if you have the same base, but the powers are different, like a rational number a by b raised to the power m is equal to the same base, that is the rational number a by b raised to the power n, then you can say that m equals n. So these two will be utilized in solving today's problems. We have two categories of problem: simplifying a given expression and solving for an unknown variable, which usually will be in the exponent or power or index. So I hope the laws are clear that we will use in solving today's problems. So let's now solve the problems. First is the simplification. This problem is from the exercise 5a. This is problem number 15. We have to simplify this. Now, so we see that it's a rational number where the numerator is a product of some exponents. 3 to the power 3 to the raised to the power 5 is an exponential form, and 10 raised to the power 5. Similarly, in the denominator we have 5 raised to the power 7 multiplied by 6 raised to the power 5. Now, the general strategy to solve this kind of simplification problem is that you break you break the base. If you can factorize the base to some factors, you break that, and you you use this formula law, that is, this is a to the power m multiplied by b to the power m. So AB, AB you have to factorize that to a and b, and then you separate out a and b with the power. Okay, so now in this case we can see 3 cannot be done anything, so 3 raised to the power 5 is fine. Now 10, we know that 10 is 2 into 5, and we have raised to the power 5, and 25 we can say that 5 raised to the power 5 square. So we have 5, this cannot be broken down further, and this 6 can be broken down as 2 into 3 raised to the power 5. Now this becomes 3 to the power 5, and using the law I have stated above, 2 into 5 whole raised to the power 5 becomes, we separate out the factors, 2 to the power 5 multiplied by 5 to the power 5, and we have 5 square divided by 5 raised to the power 7 multiplied by, similarly we separate out the factors with the power, so 2 raised to the power 5 multiplied by 3 raised to the power 5. Now we see that in the numerator we have the bases 3, 2 and 5. Also in the denominator we have bases 5, 2 and 3. We have to cancel all the exponents having with the same base. So clearly we can see that 3 to the power 5 cancels out. 3 to the power 5 in the denominator, it is also in the numerator. What else? 2 to the power 5 is also in the denominator, it is also in the numerator, so it cancels out. And so we are left with 5 raised to the power 5 multiplied by 5 square divided by 5 raised to the power 7. Now this is we can utilize the fact that a to the power m multiplied by a to the power n is nothing but a raised to the power m plus n. We have already seen this in the previous video. The law is nothing but the first law. Okay, so this becomes 5 to the power 5 plus 2 divided by 5 to the power 7, and this is 5 to the power 7 divided by 5 to the power 7, this is 1. So the answer is 1. I hope it's clear. So basically you have to see if you can factorize the base. You factorize the base and then you separate out the factors with the power. In that way, you will see a lot of things will get cancelled. Okay, let's see the question number 16. Over here we see it's also a simplification problem, but we have a in the power exponent we have n, and it's not a constant. I mean it's a variable, but we have to see whether the final result has n or not. So over here we can see all the powers of 2. Okay, and also the denominator and both the denominator and the numerator are difference of difference of exponential products. Okay, so let's do it step by step. We see that 16 is see. So we see 16, 2 and 4. It's better we all convert all the numbers as a power of 2. So 16 is 2 raised to the power 4 multiplied by 2 raised to the power n plus 1 minus 4 is raised to the power 2 multiplied by 2 raised to the power n. Okay, again 16 is raised to the power 4, 2 raised to the power 4 multiplied by, we have 2 raised to the power n plus 2 minus we see over here it is 2 multiplied by I hope I have, let me check once again if I copied the question correctly or not. This was 16, question number 16. Where is it? Question number 16. Yeah, it is fine. So now this is 2 multiplied by 2 raised to the power n plus 2. So this becomes 2 raised to the power n plus 2 plus 1. No, we have. I will not do this. We have to check what powers to keep so that we can cancel some common factor from the numerator and the denominator. So let this be 2 into 2 raised to the power n plus 2. Okay, now okay, so n plus 6 and n plus 2, n plus 3. Now 2 to the power 4. Now this is 2 to the power 4. I am not yet adding the powers. Now this thing is 2 raised to the power n plus 2 divided by this is 2 to the power 4 multiplied by 2 to the raised to the power n plus 2, and this is minus 2 n plus 2 raised to the power n plus 2. Now clearly we can this thing is only common from all the 4 numbers. As you can see, the numerator is difference of 2 numbers and the denominator is also difference of 2 numbers. So from in all these numbers, this number, this number, this number and this number, the common thing we can see is 2 raised to the power n plus 2. So now this thing 2 to the power 4 multiplied by 2, we can 2 to the power 4 we can say is 2 to the power, we would like to have 2 raised to the power n plus 2 over here, n plus 2. So I need 1 2. So I will borrow 1 2 from 2 to the power 4. So 2 to the power 4 we can write it as 2 to the power 3 multiplied by 2, and this is 2 to the power n plus 1 minus 2 raised to the power n plus 2 divided by let this be 16, 2 to the power 4, let this be 16 because now this is 2 raised to the power n plus 2 minus 2 2 multiplied by 2 raised to the power n plus 2. Now this is 2 to the power 3 is 8 and 2 multiplied by 2 raised to the power n plus 1 is 2 raised to the power n plus 2 because 2 means 2 to the power 1 and over here we have 2 n plus 2 divided by 6 divided by 16 multiplied by 2 raised to the power n plus 2 minus 2 into 2 this. Now if you see, I can take common 2 to the power n plus 2 from all the 4 numbers. I mean I can write the numerator as 2 raised to the power n plus 2. I am taking this common and this is 8 minus 1. And also from the denominator I am taking 2 a common 2 raised to the power n plus 2. So this becomes 16 minus 2. So from both the numerator and the denominator 2 raised to the power n plus 2 gets cancelled and we are left with 8 minus 1 divided by 16 minus 2. This is 7 by 14 and this is half. So the answer is half. So you have to carefully think about in most of the cases you will have to take some common and that common will be some base raised to the power, it will be in some exponential form. So you have to carefully observe what how you would like to break down the base so that you can cancel out things in an easy way, so that the simplified value will not have n involved. It will be a fixed value. So you can while I am solving, you can pause the video and take a screenshot. Okay, now let's do the problems for solving for unknown. So question number 14 says that find x such that 3 by 5 cube multiplied by 3 by 5 raised to the power minus 6 equals 3 by 5 raised to the power 2x minus 1. Here x is the unknown. Now okay, so it is given that 3 by 5 cube multiplied by 3 by 5 minus 6 equals 3 by 5 raised to the power 2x minus 1. We can clearly see this is an equation and we have some exponential form where the base are same, that is the base is the rational number 3 by 5. So we can clearly understand that we have to create an equation of the form. We have to create an equation of the form a by b raised to the power m equals to a by b raised to the power m, so that we can equate say m equals to n, and from here we can solve for x. So this equation implies that we can, on the left hand side, can be simplified as, since it's a product of two exponents where the base is same, powers are different, so the powers get added. 3 by 5 raised to the power 3 minus 6 equals 3 by 5 raised to the power 2x minus 1. Now this implies 3 by 5 raised to the power minus 3 equals 3 by 5 raised to the power 2x minus 1. Now we can straight away apply the law on the right hand side that I have written, and this will imply the bases So this is one exponential form has been equated to another exponential form where both the exponential form has same base 3 by 5. So their powers should be equal. So this implies minus 3 should be equal to 2x minus 1. And solving this, we get that 2x equals 1 minus 3, that is minus 2. This implies x equals minus 2 divided by 2, that is minus 1. So minus 1 is the answer. X equals minus 1. Okay, let's solve another problem, that is question number 18. It says if 2 raised to the power n minus 7 multiplied by 5 raised to the power n minus 4 equals 1250, then find n. Now we can clearly see that the left hand side we have the product of two exponents where the bases are different. Bases are different. Bases are 2 and 5. So somehow we have to, at the right hand side we are given a fixed number, that is 1250. Somehow we have to convert the number 1250 as a product of two exponents where one exponent will have base 2 and another exponent will have base 5. We have to somehow convert 1250 in the form given on the left hand side. Now 1250, let's see how we can break this down. 1250 equals, let's factorize 1250. So 2, if I divide by 2, this is 625. Okay, now if I divide by 5, I have 125. I am prone to make mistakes. Please do let me know if I am doing any mistakes, any silly mistakes in the calculation, and let me know in the comment section. I will highly appreciate that. So when I divide by 5, it is 125. Okay, then again I can divide by 5. This is 25. Then again 5. This is 5, 5, 5. So I can see that 1250 is nothing but 2 multiplied by 5 multiplied by 5 multiplied by 5. 5 how many times? 4 times. 4 times. So this is 2 to the power 1 multiplied by 5 to the power 4. 5 multiplied 4 times, we in the exponential form write it as 5 raised to the power 4. So now if this is the case, then clearly we can see that 1250 has been written in the form 2 raised to the power 1 multiplied by 5 raised to the power 4, and it is given the left hand side that it is 2 raised to the power n minus 7 and multiplied by 5 raised to the power minus n minus 4. So this obviously this should mean that we can now equate the powers of 2 and the powers of 4 on both sides. On both sides, that is the power of 2. We can equate the power of 2 in the left hand side and the right hand side. That is, the power of 2 in the left hand side is n minus 7. I can equate that to the power of 2 on the right hand side, that is 1. This clearly solves n. This implies n equals to 1 plus 7 equals 8. So you got n by equating the power of 2 on both sides. Now if you equate the power of 5, if you equate the power of 5 on both sides, you will get the similar result. If you do that, if you equate the power of 5 on both sides, n minus 4 equals 4. This implies n equals 4 plus 4 equals 8. So n is 8. N is the answer. Okay, let's solve question number 17. There are three parts. First part says 5 to the power 2n multiplied by 5 raised to the power 3 equals 5 raised to the power 9. So the concept is same. You have to you are given an equation, and the both sides of the equation you will see an exponential form, that is a base raised to the power some exponent, and from there you have to equate either the powers or the base. Now this implies on the left hand side I have a product of two exponents where the bases are same. The base is 5, so I can merge them together and write 5 to the power 2n plus 3 equals to 5 to the power n. Now this implies that 2n, the bases are same, so the powers should be same. 2 plus 2n plus 3 equals 9. This implies n 2n equals 9 minus 3 equals 6. This implies n equals 6 by 2 equals 3. So n is 3. Okay. Let's do question number part 2. Part 2 says 8 multiplied by 2 to the power n plus 2 equals 32. Okay. Now we can see that 32. So since we have a power of 2, the unknown variable is in the power where the base is 2. We have to convert every other fixed numbers as a power of 2. So I have to convert both the left hand side and the right hand side as in exponential form so that the base is 2. That is the primary objective to solve this problem. So 8 I can write it as 2 raised to the power 3, and this is 2 raised to the power n plus 2, and 32 I know is 16 is 4 into I know 16 is 32 is 16 into 2. This is 4 into 4 into 2. This is 2 square multiplied by 2 square multiplied by 2 to the power 1. This is 2 to the power 5. Okay. And the left hand side also we can merge. We see it's a product of two exponents where the base is 2. So it will be 2 raised to the power 3 plus n plus 2 equals 2 to the power 5. So this implies 2 5 plus n equals 2 to the power 5. Now we see that we are having equality of two exponents where the base is same. So we equate the power, that is the exponent. This implies 5 plus n equals 5. This implies n equals 5 minus 5 is 0. So n is 0. Okay, n is 0. Fine. Let's do part 3. What is part 3? Part 3 is where is part 3? 6 to the power 2n plus 1. 6 to the power 2n plus 1 divided by 36. Divided by 36 equals 6 to the power 3. So we have a division going on. It's okay, no problem. So this implies this is 6 to the power 2n plus 1, and since we see the right hand side we have the base 6, we would like to, and also we see an exponent with the base 6 on in the left hand side. It's better we convert every exponents in the form so that the base is 6. So 36 we know that it is 6 square equals 6 cube. Now we know that we have seen that a by b raised to the power m divided by a by b n equals a by b raised to the power m minus n if m is greater than n. Now in this case we have also a division where the common base is 6, but we don't know whether 2n plus 1 is greater than 2 or not, or do we know 2n plus 1? Now if n is 0, if for some reason n becomes 0, let's assume that 2n plus 1 is greater than 2. Let's assume in that case we will have 6 to the power 2n plus 1 minus 2. As you can see on the right hand side, I have written if m is greater than n, then we have a by b raised to the power m divided by a by b raised to the power n is a by b raised to the power m minus n. So I am assuming that 2n plus 1 is greater than 2. Assuming, it may be false. The assumption may be turn out to be wrong. Then I have to proceed by using an alternative path, that is by assuming 2n plus 1 is less than 2. So as of now I am assuming 2n plus 1 is greater than 2. So if I assume that, then I will have the left hand side as 6 raised to the power 2n plus 1 minus 2. This is equals 6 raised to the power 3. So now I can equate the powers. Since the base is same 6, I can equate the power and say 2n plus 1 minus 2 equals 3. Now this is 2n. Okay. Now we assumed that 2n plus 1 is greater than 2. That is for sure. The assumption is right, because we see on the right hand side the power is 3. It's a positive power, 6 raised to the power 3. So definitely 2n plus 1 minus 2 will be positive and will be equals to 3. So here we have 2n plus 1 minus 2 equals 3. So 2n minus 1 equals 3. This implies 2n equals 3 plus 1 equals 4. This implies n equals 4 by 2 equals 2. So n equals 2. Okay. So this one, I don't think I have any further problems. Let me check. No, I have no other problems. So this was the problems that I wanted to solve. To discuss the application of the laws of exponents, the three special laws of exponents, which are 6, 7, 8 as per the notes, and to solve two categories of problem, that is simplification and solving for an unknown in the power in an equation involving exponents. So I hope this video was beneficial and it helped you to understand the concept of laws of exponents and how they can be applied to solve problems. Now there are few other problems, variations of problem I will see, and probably there will be either one or two more videos on the laws of exponents. So please stay tuned for the upcoming videos on the laws of exponents, and with that we will come to an end to the chapter exponents, and we will move on to the next chapter. So thanks for watching, and once again, if you are not yet subscribed and if you are watching my videos on regular basis, please support me by subscribing to my channel. And if these videos are beneficial, then please do like them, share them with your friends, and also do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.